I'm going to solve the flipping coins problem. So let me just jot down some of the key information. My number of trials, I'm going to call them, is 3. I'm going to do this thing 3 times. And I'm really interested in counting the number of heads. So x is my random variable, my discrete random variable in this question. And I'm going to answer several questions. First of all, probability of x is 0. So number of heads is 0, means that I need tail, tail, tail. There's only one way to do that. So I need probability of a tail is a half, 3 times, so probability 1/8. Probability of x is 1. To get one head, tail, tail. But of course, I can do this in 3 ways. The head could come on the first, the second, or the third flip. So I've got 3 lots of probability half, a half, and a half. So it's still a half cubed. So in this case, 3/8. Probability of x is 2. So I want 2 heads and a tail. And of course, this problem's symmetrical. There's 3 ways of doing that as well. The tail could come in one of 3 positions. So again, 3 lots of a half cubed is 3/8. And then finally, x is 3. Of course, I need head, head, head. There's only one way of that. So I've got a half cubed is 1/8. Just check this, 1, 3, 3, and 1 adds up to 8, so that's up to 1. That's fine. So that's the situation for 3 trials. If I now look at the next question and think to myself, well, what happens when n, now number of trials, becomes 4? Let's go through the same process, and I can exploit the patterns that I've already started to observe. So probability of x being 0, well, I need tail, 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 tail. There's one way of doing that. So of course, it's a half to the power of 4, which is 1/16. Probability of x is 1. I want 1 head and 3 tails. 4 ways. 4 positions in which the head could appear. So 4 lots of a half to the 4/16. I'm not going to cancel that down because it'll make it easier to total them up in a moment. Probability of x is 2. Head, head, tail, tail. Now here I've got to think, how can I do this? What am I doing? I'm arranging 4 things, 2 of which are heads and 2 of which are tails, which is 6, which is also 4 select 2, 4 choose 2. So here I've got 6 lots of a half to the power of 4, 6/16. Probability of x is 3. Head, 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 tail. Symmetry with this one. I know there are going to be 4 ways of that. 4 lots of a half to the power of 4. So 4/16. And it gets easier again now. X is 4. Head, 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 head. Only one way of that. A half to the power of 4. 1/16. Let's just check this. 1, 5, 10, 16. Yeah, adds up to 1. So I've got the probabilities for 4 trials. And if I understand the way this works, I can now go on and answer it for any question. So for the last part of the flipping coins experiment, if I say number of trials is now 10, probability of x being 1, well, I know that if I've got 10 trials, I'm going to have a half to the power of 10. To get 1, I want 1 head and then the rest of them to be tails. I know there are going to be 10 ways of doing this. I know that there's only 1, so it can appear in 10 places, or the other way I know that is to do 10 choose 1, which is 10. So I've got that one. If probability of x being 4, probability of getting 4 heads, the half to the power of 10 remains the same. But if I've got head, 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 and then the rest are tails, of course I've got 10 choose 4. So the coefficient here, 10 choose 4. And if I've got my calculator, I can work that out. For the moment, I'm just going to leave it like that. What I am going to do is very quickly summarize at the bottom. If I've got number of trials equaling n, then the probability of x being any particular number that I choose, let's exploit the pattern, it was always a half to the power of the number of trials that I had, so in this case n, and the coefficient was the n number, select the number that I was looking for, NCR. So in actual fact, I've got a formula for the flipping coins problem for any number of trials and for whichever question is asked.